Okay, let's try to have this kind of interactive session, more like an interactive session than not really a real presentation. If not, I'm going to speak by myself for 3 hours. No, we try to interact and try to use in the main time that I'm speaking the to log into the HPC and try to run in the scripting that I'm going to use it. So how many of you have already used HPC? 2, 4, 5. Okay, but running one job or running several jobs? Okay, because something is running one job, you enter in the login node and you run the job, mistake, big mistake. Or you submit to the queue one job, it's already better. Or you submit 1,000 job in multi-core processing, that's great, okay? This is how we should go until the end of the day. Okay, so I sent the information how to log into the Surf cluster, and if everybody did it, you should be able to, let me zoom in this one. So you should be able to add in directly your account, where your account is your name, probably with student and then the number at SpiderSurf, not Netherlands. Okay, so this is the typical way to connect to a cluster. All the cluster, they have SSH connection, and you can always log in this way. Okay, so this is replicate more or less what you can see in the prompt in your Bash Unix system, where you have the user at this computer. In my case, I'm the user self. At my computer is Pop OS. When you connect to the server, you can also allow the SSH, you can also allow the X terminal panel opening. What does mean? That you can pop up eventually some other software that are needed, the X term. So when you open a second Windows. So when you enter, if you did everything correctly, you should have the welcome message from actually from Raymond directly. It's a bit too big. SSH. So how many of you already entered inside to the Surf? Okay, so quite a good number. I'm entering another way.
Giuseppe?
Yeah.
If you do an ls on /home, you'll see who is logged in.
Sorry?
If you do an ls on /home, you'll see who is logged
Yeah,
in.
I will explain everything. Okay. Try to, okay. Okay, sorry. Okay, it's very common also to, it's very common, and also I suggest to open 2 terminals to the same account, okay? Into the same server. In this way, you can shift very fast with Control Alt, or sometimes is also Control the tilde, the button below ask. So it's very common because you can be in two different directories in the main time that you are working. You can be in the scripting directory in one terminal and the data directory in the other terminal. Okay. Perfect. Let me zoom also this one. Okay. So just a bit of background. Whenever I do I start when you enter, you are in your home. Okay. So if you do print working directory, you are directly into the home and you can see what is the address of your home. That, as you can see, is the same user login node that you use to enter in the login node. As soon you enter in the cluster, you are in the login node. The login node is as the name say, for logging, not for working. You can list directory, you can count how many files there are, you can open a script, but you cannot running a process, especially if it's using a lot of RAM. Some accounts, some HPC, they have even a quota for each user in terms of run inside to the login node. Now, I don't know this one, but probably if you asking too much, you are going to realize it's going to be kill you immediately. I mean, kill it in the job term. Okay, so whenever you do the ll/, you are going up into the operating system. Okay, more than this, there is nothing else. So don't make a mistake in the path. So we assume that the path knowledge about the bash is already taken. So as you can see over here, you have the typical structure of bash Unix operating system. So there are the typical file folder that are this one, the typical bin, boot, catalog, and so on. And there are some that are really peculiar to this cluster. In particular, the LL project is the one that we are going to use it. Okay. So if you do LL project, you can see that there are many projects. Among them, there are the Geocom course, like this. Okay, the Geo course inside here, we have some folder that is the data where we are going to have some data for you guys. Okay, and then also the software that we are going to install it, that we have been installed. Okay. Okay, so here we have the software that has been installed. For any problem with installation software or something related to installation, you can ask Raymond and also Francesco Lovergine. Francesco, say hi. Yeah, Francesco is also a good expert in installation stuff and is helping Peter and also Antonio to installing their own software. Okay, perfect. So, and anyone you can follow me online on this one, I mean, on the terminal with all this information. Okay, perfect. So we are going to use this web page that I send it in Discord. Okay, so if you log in inside spatialecology.net, then you scrolling down and you can see that we are going to use the HP session. You are going to first running the script in this one, and then later on go into the grass session. Okay, so this is the typical infrastructure of the HPC. So at the moment you are working from the from your computer and you are logging into the login node. The login node is one, sometimes can be even two if there are many users, but all of them they are linked with high performance cable and so on, something that has been covered by Raymond, to each single unit. Okay, each single unit is nothing else than a kind of replication of structure that is present over here. Okay, so what does it mean? That each node will have a bin, a /dev/etc net and so on. They will have all these folders, including some older folders that are very important. Okay, so each single computer, single node can be considered as a single computer, like your laptop. Okay, so we will work in such a way that we will running job, and each job is going to send to one node. Okay, and inside one node we are going to use more CPU. We can send another one to another node, more CPU. We can send another one to one node, more CPU, and so on. What we cannot do it, because it's much more complex, is sending one job to two nodes that are sharing all the CPU together. So this is the RMPI stuff, OpenMP, that is much more complex, so we are not going to cover. So we are doing really simple parallelization. Okay, perfect. So every time that you do something in the terminal, okay, like a command, everything that is printed in the terminal as a result of the command is called standard output. Rather, everything that is printed at the terminal but is an error, like command not found, is called standard output and standard error. So this is the so-called standard error. Also, every time that you're running a job, the jobs per se is producing a standard output and standard error. Okay, so if you want tracking these two information, standard output and standard error, for each job, for understanding what you are doing. Okay, so these are stored in text file, then later on can be opened inside to the terminal, and in particular they are going to be stored inside to this directory that everybody has to create now. Okay, so please running this command inside your terminal. Okay, and to me is going to tell that the file already exists, but in your case is going to create the two folder. Okay. So inside your home now you will have just these two folders that has been already created. So check if you can see these two folders because they are going to be important for saving your scripting procedure. Okay. I leave you a bit of time with this one too. Okay. And then, of course, if you are a bit behind or something is not working, just raise your hand and some people from the teacher group is going to help you. Okay, perfect. Okay, so quite often is also very common to working directly inside to the login node to editing your scripting procedure. So this is something that can be done. It's not because it's not RAM consuming. Okay, something that I really try also mention to my students, also to colleagues, is always try to have one area where you're saving your scripting procedure. And your scripting procedure most of the time need to be your home. In your home is the one that most of the time is backed up. The other one are not quite often, okay? So create immediately also a folder that you call it script, okay? Inside to the script, you are going to put all inside to this folder that is called script, only the script, not something else, not the data and so on. Why not data and so on? Because if you have a folder with all your script, then later on you can link this folder with your GitHub account. So if you don't have file there, it's much easier, okay? And you are less in trouble. So over here, you can also create a folder with the project that you are working. For example, we are going to working first with the GladRD. And you can call it GladRD, the folder, okay? So inside here, did I write correctly? Yes. Inside here, you can go to save it later on the scripting procedure that we are going to run it, okay? So keep in mind this folder as your working folder for this project. If you have account in other HPC from your university, try to working for this morning and understanding how the HPC work, okay? And then use your university HPC. They're going to be pretty the same. Maybe what is changed is just the structure of the path and the folder name, and that's it. Most of them, they're going to use SLARM, and the SLARM is the queuing system for the HPC. There are also some other, but so far this one is the most used one. Perfect. Okay, so we were in the process of using and editing and using a terminal for writing script. Okay, So most of you already use a Jupyter Notebook, and some other teacher they're going to use Jupyter Notebook for in the cluster. So what I see, the Jupyter Notebook can be used if you pre-allocate some node in computation, but you cannot really sending and submitting job to the queuing system. So rather you have to do it with a real plain text scripting procedure. Okay, there are mainly two different groups of let's say developer. The one that are using VI, okay, for editing test, and the one that are using Emacs. Okay, Emacs and VI, they are very old text file software for writing text. Okay, nothing else than writing text. You can select both of them. You can select both of them. I always use Emacs, and I don't use VI. So when you call Emacs directly, maybe you can wait. Let me see if you is opening. You can see now, for example, that is not working very fast. Why? Because he's calling from the X term, the so-called, when we started with X, is calling the X11 term. So this one create a lot of latency in the job. So in working, actually is even failing because there are not some models. So I can kill this process, and I can call Emacs directly on the terminal with the NW not window, and this one is going to open a testing directly in the terminal. This is nothing else than a text that you can write, and this is extremely fast. You don't have latency. You can work even with your mobile, and you are editing a test directly inside to the terminal. VI is perfect the same concept. Okay, what you have to learn it in this one is that you don't have the mouse. Okay, so you have to have few options to save the script and to close it, at least now. So I'm going to tell you for Emacs, because it's the one that I use it. So to save it is Control XS together. So usually you do it with the left hand together, Control XS, and then to close it, Control XC, and you close it. Okay. As soon you have it, if you see that you have done correctly, you can open this one and see if you edit what you edit. Okay. So usually what you do it, you have one terminal open with the scripting procedure and the other one ready to run the job. Yeah.
Not a question per se. I was just going to say that some people also like the nano editor, which is a bit more modern, that also exists on the system. So if you don't like Emacs or VI, which are a bit more archaic, nano also exists, and gedit as well, a few others.
Okay.
So there are a few options. If you don't like it, just let me know and I'll help you.
Yeah. Cool. All of them, they are perfect the same. They are editor of text file. Okay. So once again for Emacs, Control XS to save it, Control XC to close it. Okay. It's very common to have one terminal open with the scripting procedure and the other one ready to launch the job. Okay. So let's try to work in this way with two terminal and shifting from one to the other one. Okay. So before to enter in the scripting procedure per se, we need to make some modification to the one specific file that is called the so-called bash rc, where is called bash resource. Okay, so this file is a hidden file. And why is hidden? Because all the files that starting with dot, there are hidden file inside to the home. And here you can see, okay, you can see that all these files are present in the home, but when you do LL, you don't see. And there is one in particular that is the .bashrc, that is the one that we are going to edit. Before to edit, let's have a look. I can use cat to print in the terminal this bashrc that again is nothing else than a text file. Okay, so over here you will see that your bashrc is up to here. Okay, it's just this part. And we are going to adding more part over here below to having all our setting ready to operate inside of HPC. Perfect. In order to do this, how we do it? Go back to the other terminal. I close it. This one that was just a terminal. I remove it just to be sure that I keep everything clean. Okay, and I'm going to open that file. So now pay attention about this. I open the file, we say with Emacs, not window, and you call .bash rc, bash resource. Okay, so now you have over here, so you can getting all this line that you have here, okay, and paste directly below your Emacs file, okay. I will wait as soon. So over here you can paste, okay, and you are going to have everything.
Yeah, Giuseppe, there's a question in the room.
Yeah. Just get from a friend. Yeah, no, it's not a laughing. No. Let's learn another stuff. Okay. So everybody's logged into this machine, okay? Everybody's logged into this machine. So everybody have access to the same folder, okay? And in particular for this kind of trouble, there is the TMP that is visible from everybody, okay? So if somebody put the TMP, look now I'm putting, actually, yeah, get it from a colleague because mine is a bit modified. So you do copy bash drc. So some of you do for Samuel, no? You say, yeah, bash rc and put inside to the /tmp, okay? And then you can do the opposite, okay? So you can enter this one and then you can do the opposite. Copy from /tmp to /punto, yeah, dot bash rc to my home, okay? And then you can retrieve the bash rc because the bash rc, the default is equal for everybody, okay? Then when you customize, then it's different from the different people, okay? But we are in the beginning, so you can get it from somebody else. And this is valid for the bash rc, but also if you want to transfer files from two people, from two home, you can transfer through the TMP, okay? Okay, the TMP is called TMP, and every time it's shutting down, is going to be raised, okay? The maximum you can do DF, no? DFH?
The TMP normally should not be used like this. I mean, we do discourage it. It can be done. I don't want
Oops.
The project space and then the GeoCourse share folder is really meant for sharing files.
The what?
/projects /GeoCourse /share with a capital S. That is the folder meant for sharing files.
Okay, but it's a small file, so it's not hurting. And then if you do fast, you remove it. The IT will not know. No.
The TMP works perfectly well, but it's not a good best practice in this case.
Okay, so which one you say? LL?
So /project /GeoCourse and then.
Yes. Okay, the typical project. Okay, so this one is that where we are working. Okay, so especially if you are transfer file, of course, this one is the best location. Okay.
That's why it's good to have a computer supervisor in your room, just to stop all illegal actions.
Perfect.
Time.
I might have done the same in the past.
Okay. So as soon you copy all the line inside to and that one you can do with the right click, copy paste. Okay, you should have all this line inside to the bash rc. Okay, and that are once again are these one that are around over here. And then in the meantime, I'm going to explain what they are doing, and we will go to use quite intensely this stuff. Okay, so these one are alias, and they are special command that everyone can build and be used in the different purpose. So I built some, specific for looking the standard error and standard output of the scripting procedure, but you can build whatever you want as alias. So as you can see, the alias, you have one name that identify the new command plus the combination of other command to do some kind of operation, okay? So these are very well known, very well known. I use it quite a lot, and we are going to use it. But feel free to modify, adding some other information. So this other link over here, are nothing else that software setting for allow to use the modules that we are building, that we built inside to the project library software folder. Okay, so be sure that you all of them are copied inside to the bashrc. Perfect. When you copy, as soon you copy, you have to do, like we say, Control XS to save it, and Control XC to close it. Okay, so if you want to see if your file has been done correctly, you can do more to see if whatever you paste is there. Okay, so you can do more to see. So I leave a few minutes that everybody should be online in this aspect.
Giuseppe, for saving, you say Control XS, and for exit?
Yes, Control XS, and for exit, Control XC.
Okay.
XC. Okay, and then there are much more. If you just Google it, Emacs shortcuts, there will be another 4 or 5 to use it, but these are more than enough. So as soon you modify, you save the bashrc, there is something that you have to do it in order to have everything is to source the bashrc, okay? To reread the bashrc. Okay, so when you source it, the bashrc, all your modification need to be getting from the terminal. So this operation, of course, you have to done only once. Every time that you will open a new terminal is going to be perfect the same. So it's going to be automatically, okay? Because every time that you open the terminal and every time that you're running a job, the bashrc is going to be readable. It's going to be read directly, okay? Keep in mind. Okay, a few minutes more for this bashrc. And to test, you can try one of the alias that was there. So if you do alias, you can see, you can test some like L, okay? Or I have some that are probably not in the list, or my queue, and we will see what they are. So you can test a few of them. Okay. So let's move to the understanding how the queue is considering the SLARM before to submit any job. So by this command, you can see what are the jobs that are running. Okay, this is all the queue that are in the HPC. So you can see that if you go in the beginning of this list, and you can get Okay, so you can get from the beginning that you have the job ID. That is something extremely important. We are going to use how it works. The partition, the name of the job, that is something also extremely important, the user that you are, each single user of you, and then this one is the R. As you can see, all the jobs are running, so means that there are no pending jobs. We will see that we are going to start immediately the job that we are using. Okay, so something also extremely important and check out is the time that you that your job is going to run. Okay, that is running, let's say, and also this one is the node where is located. Okay, for the example that we are going to use it is going to be a really simple example, and is going to be working this way. We have a simple raster file that is going to be split by the first job in 4 different tiles. Okay, so this one, the raster is going to be split in 4. Every time, most of the software that we are going to use, GDAL, PK tools also, and GRASS, they don't have most of the time an internal parallelization for doing the stuff easily, but you have to do tiling, retiling, and remosaic to do some operation. Where you do it, this one you divide in 4, for example, each single tile can be sent to a CPU, and it is becoming a single independent job, or a combination of action that we'll see together. Okay, so we will have a first script that is going to be a really simple script to split a raster file in 4 different files. Okay, so let's see immediately the script below and without running, and then we come back to the other one. So the first script is going to be set up by this first command that are the typical command of the SLARM initialization for running a job. Okay, so we have the most important one, that is the queuing system. So inside to the surf there are different queuing, and we have normal, short, and then there is also one dedicated for the course. So in this case, I set up the usual one, the normal, but we can even shift to the other one. Anyway, to the one that is reserved. But anyway, they are so small, the job, that they are going to be run immediately, even if we leave the normal one. Okay. So these are a particular setting for reservation for our course. Okay, this is the name of the script. Okay, the name of the job, that is going to be the same of the name of your file in your computer. Okay, don't start to have different name and different option. So then this one is also something very important, that is giving to us how many node we are going to use it, and how many CPU. Okay, and this one, the small one, is how many tasks. Okay, so this one is going to be also quite particular, and we will get the support a bit from Raymond to understand very well all these 3 parameters. So once again, the N, remember the capital letter, uppercase, that is the node, the bigger one. C stay for CPU, and N stay for task. This is the time that you are going to allocate to your job, and this one is the location of the standard output, the standard error that the job is going to be produced. Okay, so as you can see, I'm keeping constant also with all the names that are perfectly the same. So in this way, I know that if I run this script, it's going to produce this standard error with the same name plus the job ID, and these information are the one that you read over here. That's why they are important. Job ID, the queuing, the partition, the time, and also the node, but the node you don't specify over here because it's allocating automatically. Something also very important is the memory that the job is going to be used. Okay, so remember that each single node, so over here, has 1 RAM. like your computer, but many CPU. So if your RAM is 100 and you have 10 CPU, you can request maximum 100, so means 10 giga for each CPU or less. So you cannot requesting 20 giga for.
Just one quick thing. The memory option is preferred not to be used on this particular system. It can lead to issues on the scripts.
Can be automatically?
The scaling is that you're getting, depending on what node you're asking for, a thin or a fat node basically, you either get 8 gigs per core or 16 gigs.
The default.
If you use the memory option, it may backfire on you. So the
Okay.
best way is to not use it and ask.
Not at all?
Not at all.
Okay.
Yeah. And just say I need 8 gigs, 1 core. If I need 2 gigs, if I need 16 gigs, take 2 cores, something like that.
Okay, so we'll do it automatically.
Yes. Most applications we see do not respect the memory very well. So if you actually go over time, so we decided to not kill jobs based on memory. So you're even allowed to over provision a little bit. If you look at workflows and let's say end user applications, the memory may fluctuate. So if you were for a millisecond going above your memory due to some way that you're doing a calculation, your job stream would kill
Yes.
it. So instead we decided, okay, let's do a scaling and tell the users what the scaling is that on average you expect, and not kill any jobs based on memory. So try to respect the scaling, but if you use the memory option in the way it's set up now, it may lead to weird behavior on your job. So it may, the way the scaling is set up compared to how the memory is set up in Slurm, you may get into issues.
Okay, perfect.
Try to avoid it if possible. It may not end on this example, it may be okay, but for more complex settings, it might be difficult.
Okay, thank you very much, Remo. Anyway, some of the HPC, they have the MEM requirement that you have to, and if you don't specify, you get a default, and the default can be very low. Okay, so once again, this is set for the memory allocation. So we will modify the script, and this way you also learning how to do it, removing completely this line from the script. Okay, perfect. So then this is the line that I usually paste immediately under the different option for the Slurm. That is the name of the script with the full path of allocation. In this way, if I want to run this job, I just over here copy, paste inside to the terminal and run immediately. So I always use it without even searching where is the path and so on. So this is nothing, it's just a comment to run that script, okay? So let's see the models. So when we put in the bash RC, this for line over here, where we define the path for loading the models, okay? So every time that you are in the terminal now, you should be able to see all the models that are available under your environment because we install it. So if you do module avail, you can see all the models that we have been installed, okay? And as you can see, we have installed GDAL, grass, and of course, when you install a GDAL grass, is also carry over all the different how you call it, library that the software need, okay? So you can see and maybe recognize even some of them. Okay, so if you don't remember, so you can get a list, but you can also search for a particular software. So, and with the word spider, so if you do model spider GDAL, you can see that GDAL is coming out, okay? And this is the name of the modules that is loading every time that you call module load, and the name of the modules is going to, let's say, open the door of GDAL. So if you do like this now, GDAL is not going to appearing. GDAL translate. Okay, so as you can see, tell module not find, but if I do module load GDAL, okay, let me hide this stuff. module load GDAL, then okay. We already destroyed something. Oh, low. Sorry. Okay, so now that the module has been loaded, as you can see, that does not retrieve any error. Now I can do GDAL translate, and I can see that all my GDAL commands are available for me, okay? So be sure that you can do this kind of operation. Once again, to have the list, if you type GDAL, you press tab twice, and you get the list of all the modules of GDAL modules. So a few minutes also to be sure that everyone have access to the modules. Sorry? Yeah. Now I'm going to explain everything. Yeah. Okay. So if you run model GDAL load, okay, for the people that are asking me where are the different data, I'm going to explain where are the data and where are the script. So no need to download it. So please follow the same step that we are doing. Okay, so the GDAL command, once again, for having the GDAL, you just type GDAL, and then if you press tab twice, you will get the full list, okay? Please use the tab for file completion, path completion, directory. If I want to enter in the directory GLAD, okay, if I want to list GLAD, don't start to type GLAD, use tab to complete, okay? Because if you type something else and the tab is not working, don't continue to say GLAD, it is here, no, means that is not that one the path, okay? So use the tab as much you can, and you become faster, and also you avoid type a mistake. So this one for the people online and also the classes, okay? Okay. Then okay, this one. So let's go back to this. Okay, perfect. So now we are going to transfer the scripting procedure from the location where it's stored to your machine in order to edit. So be careful about this. So I prepared the script, but you are going to also to edit and do it a bit of homework to run in a proper way. Okay, so so the scripting procedure are saved inside to this folder, okay? And if you did correctly, you should have also create a folder that is called script GLAD, okay? So at this point, you can do like this. You can select all the script, all of them, copy to your script GLAD-RD. You copy all of them inside there. Okay? All of them inside GLAD-RD. Actually, even better if you just type in this way, you also learn HPC. So we are going to use only the one that I'm using, .sh. So all the files that start with HPC and they are .sh, in this way you don't copy the PyGeo for now. Okay, so once again, if this command is returning an error means that you have error inside to the path. Okay, if I do something like this, for example, is going to tell me no such a file or directory. So means once again that the path is not correct. So at this point, you will have all the scripting procedure inside your terminal to be ready to modify and run. Few minutes also for this operation. Okay, now that you have the scripting procedure inside your home, you can start to modify, okay? So the first things we are going to open, okay? So you take the first script, that's 01, and we are going to modify in some special way, okay? Also following the discussion that we have, the suggestion from Raymond. Okay, once again, you can open the script, and now if you don't open the right script, your screen will be empty. So be sure that your file is there. So how you can do it, if you do an LL, you can list the file. So when you're sure that it's there and you can list it, you can open directly, okay? You can do again with the Emacs. Okay, over here, we can start to modify the script. This is the first script that does the splitting in 4. Raymond, can we leave this? Can we leave this setting for the partition? They are very small. I can use short, or I can use the one dedicated. They are, yeah. You can leave normal, or you can leave short. Okay, they are very short, like 1 minute, so they will be fine. Okay, over here is where you have to modify your the scripting procedure. In particular, you have to put over here student and the name of your ID student, okay? And this is going to be the location where you have your standard output, standard error inside to the folder. So once again, be sure that you have these 2 folders, because for any reason you didn't create, you are going to lose completely the standard error. You are not going to know where they are. Okay, so over here, student number for here, and also the one below. No, it's going to create it. Oh, it's going to be. We have a follow-up question. Why do we have one in our home directory, and why do we claim that there be no script file? Is this the output file for the data? No, this one is going to be the output for the data. Okay, and now I'm going to explain why. And the other one that we created was for the script. Okay. So I'm going to have 2 folder. GladRD is for directly under the home, is going to be for the date, for the home, for the data. Okay, so pay attention that this kind of scripting procedure, and we are going to learn why, is going to take the file that is under project to be read and do something, but is going to save the output inside your home. Okay, in this particular folder, GladRD. Pay attention that you can read the same file with the multiprocessor, so it's not going to be a problem if different users read my file, but when you write, you cannot write to the same file. If not, you have collision. And actually, sometimes you don't even a warning. Then when you open the file is crappy. Okay, you can have even a tile with missing part and so on. Okay, so be sure about this operation. Okay, so at this point that you did this modification, and once again you should modify this one and this one, you have to also modify where you're saving over here your script. And in my case, it's going to be, and should be pretty the same for everybody, if you did the same name, and the script gladrd, okay, you have the first file, this one. So you can get the full link if you do read the link.f, you can have the full link of the file, okay? Perfect. So at this point, you have this file that is going to be here, ready to be launched. And we are going to launch immediately and see what is going on. Before to launch, we can even, no, not even, we have to, like Raymond suggests, to remove this mem. So we remove this mem. And we are ready to launch, okay? Let me launch first, be sure, be careful about this, and then checking. So before to launch, check what I'm doing. So I copy this line, guys, ready? We launch the first script, okay? And I paste inside to the terminal. When I run, I should have immediately the submitted job with the number of ID, okay? At this point, I can start to use the alias that we create, my queue, that is going to retrieve. Look, there is already gone, maybe because it's too fast, or maybe there is already an error, can be both, okay? So we can see the error message directly with another alias, error L, that is going to list, look, my job is going to run now, 11:11, the standard error is completed empty, so probably is going to be fine, okay? And we can go directly inside to the output to check if my view VRT, and actually, as you know, the VRT are very small file, so has been created immediately in a very fast way. And you can confirm that this one has been created, you know, at 11:19, so has been created these four files, sorry, okay? Okay, so if you have done correctly everything, you should have this file under your gladrd dataset, please. Perfect, so there is no need to download. No, there is no need to download. The script is going to read the file directly from this folder that actually is a common project, is a common folder where everybody can read, okay? Please. The color, yes. So this one is the location of your scripting location. This one is where you have your script. Okay, be careful, that can be slightly different if you change the name of the folder and so on. Okay. So once again, if you were able to run the first script, you should. This script is quite fast, so we can see running the queue, but has been running, and you can see that has been running in two ways. First of all, your data has been created under home GladRD folder, okay? So you can see over here that has been creating. And second, under your error, home error, that one is Geocomputation teach. Okay, so we can start to use the first alias. So if you do error, you can see that probably you have only one error, okay? This error should be completely empty, so side 0, okay? And you can even list the output out, okay? When you list the out, you can cut the standard output to more, okay? And you can see that the 4 VRT has been created. So this is the typical output of the GDAL VRT, okay? The output as a message, not the output as a file, okay? Once again, you have the alias, you can read the alias. If you do alias, if you don't remember some alias, you can type alias and you can list all of them. Probably you have a bit less than me. Okay, but you should be able to use error and out. Okay.
Giuseppe, before you use the instruction, read the link to create the file path for the HPC01 split if. Can you repeat it?
So the one for creating the full path of a file, perfect. So whenever you enter, you find one file, for example, script, and you are entering without entering, try to not to enter every time one directory. Okay. So if you get inside to, you list that directory, you can list the file, okay? And then you can do read the link -F, and you get the full path. This is the path of a script file or is a path of a TIFF, any file, okay? And this one can be pasted directly inside your file scripting proceeding. This way you can run this one every time that you want to run this script. It's very, rather than searching the script and where it is, you just paste it there, you have the line ready to be submitted. Okay, perfect.
Thanks. Thank you.
Yeah, for the people online, it's better if you talk directly rather than writing in there, especially if something fast like the one before. Okay, very good. So now I think we can go back to the explanation of the different kind of job that we are going to run. Okay, so let's see. Perfect. So it means that the path. So if the error are not created, there are two reasons. If you get the submission like the ID submit, so the job has been run, but probably the path is not correct. Okay, so check the path that is inside over here in the script that has to be real. So if you do this one, you copy and you paste to your terminal, it should be a folder that exists. Okay. Okay. So let's go over here and try to be, I would like maximum attention from everybody for this part because it's the most exciting part, okay? There are different way how to running scripting procedure inside to the cluster, okay? All of them are good and all of them can be used in different conditions and all of them can be combined between them in order to have the best performance. So there is not the best one is in according to what you are doing, you can use one of these. Okay, the scripting procedure are very simple. And once again, they are using one tile to do just a resampling. Okay, resampling in GDAL, nothing complicated. In the end of the scripting procedure that does the resampling for this one, we are going to retile, to remosaic, reassembling to have back the full tile back. Okay, and these are the different way that we are going to use it. Pay attention about this, because the operation for doing the resampling is always the same. What we are changing are the setting of the job submission. Okay, so I try to give the word in according to the name of the file, in according to the operation that we are going to perform. Once again, we are going to operate always in one node, okay, or in different node, but only using the CPU that are belong to that node. Okay, so let's see first this one on the left side, and then we saw the other one in the right side. I would say let's commenting all of them, and then we start to, because we need to modify always some error, ohm, and so on. So, and then we can spend the time to change this operation. Okay, so let's see the first one that is the most easy one. So the four script, they have a letter, they are all number 2, 0, 2, and then they have A, B, C, D in order of complexity. Let's see the A, resampling in a for loop. Okay, so we go down, resampling in a for loop. Okay, I have as usual the setting of the SLARM account, SLARM setting, and you can see that I'm using one node, one CPU, one task. Okay, and I'm going to perform the typical for loop, one for each tile, the operation inside to the one node, one CPU. Okay, so once again, I load the modules. Okay, I be sure that the output is there, the dir for the output is there. I remove some file that can be already created, and then I do over here the for loop for each one for each tile. Okay, once again, I do a for loop. First combination of the loop is for this one, another one for this, another one for this, another one for this. So I'm replicating 4 times the same operation for the 4 tiles. So I'm going to have 4 times the time needed for one. Okay. So what does mean that this one, the CPU, one CPU is taking care of the 4 operation. Okay. When is useful this kind of stuff? When my RAM, my requested for this operation is so big that I cannot do multi-core. So I need to do one by one. Okay, of course, in this case, it's not the case because the files are very small. So I do a four iteration. When I finish the iteration of the 4 file, I can assemble it back my raster. Okay, so this is a typical for loop in Bash. I hope that your Bash skills are quite good. If not, speed up. Anyway, it's the typical syntax of a for loop, like the Python, but without indentation. For file in all my VRT. Do I getting the name? I get the name of the VRT, so only this part. Okay. And then I run GDAL translate to do the operation over here to have the $file back to my file name with underscore new resolution syntax. Pay attention about this one. This one is the GDAL cache max. Okay. When you're setting up this, you have a default, I think it's 2000, the default that maybe even less. The GDAL is going to use it for the cache, okay? So this one, of course, should not be bigger than the one that you request, okay? If not, you are going to be in an error. But due to what Raymond say, you can even overshooting without problem, okay? So nowadays, quite often, especially if you are going to use it computer that you pay, or even because there are some universities that you have to pay a little amount, quite often you pay the CPU time, you don't pay the RAM. So it's better to overshoot this value over here. This way your time will be less, you pay less, okay? So all tricks that you can implement it in this kind of situation. Okay, so is it clear, this first one, just a for loop, each one done one by time, 4 times the same operation. Really simple, please. Yeah, once again, what we are imagine that this file is so big that we need to split in order to do some operation. That in this game are just resampling. It can be a filtering, can be something else. Okay. Of course, now the file is not big, but I simulated that will be big. So it's much better to split in 4 and do this kind of operation. So with the for loop, you are not gaining any speed, because you need 4 times to do this operation, and actually probably will be okay to running the full file. But if your file is so big that your RAM is not enough to achieve that operation, then you need to split and do it one by one, okay? So if this one you need 100 giga and your computer is 80, if you split, it's becoming 25 each, so you can run in the 80, okay? Clear? Okay. Any one of you was already running a kind of simple job in HPC using a for loop? This is the most easy one person, okay? So this is the most easy one. Okay, the easy one, even easier is the one, just one job, boom, without for loop, nothing, like we did before. This is with the for loop, okay. Perfect. Then we try to run all of them. So now let's see this second script, and now I need a bit of help from Raymond to be sure that I did correctly. So so this is a particular situation where in the for loop, pay attention that in the for loop, you have one operation that is ending and is starting the second one, and then the third one and the fourth one. Rather, in this case of an operation with the so-called ampersand trick, let's say ampersand symbol, you are running one command, send it to the background of the terminal, and let a second processor take care. Oh my God! Now we see in the script how it goes. So it's like printing something in the terminal like this. Let's suppose that I do like this. If I do a queue sequence from 1 to 100, okay, this one is printing. Why is it not printing? Patterns. Get stuck out of the cluster. Do we have internet problem or something? Or the server is down? Anyone can log into this surf? Can you log? What they did? Yeah, yeah. My internet. Yes, I guess. Okay, let's comment it, and then I give you time to digest. I will solve this one. Okay, so in this operation, I'm going to ask again one CPU, one node, one CPU, but having each one taking care of one task. Okay, and Raymond, check if this is correct. And I'm also setting this one CPU per task 1. So I'm going to do it perfect the same operation, but each line is going to be sent into the background, but this ampersand in the end of the terminal. Okay. This is quite unique way. How much time I use it? Rarely, but it's good to know. Okay. There is an advantage of this, that the full operation of this is going to be finished, all of them, when you have, thanks to the use of the wait command. So every bit will be over. This one is going to be holded until all the 4 processes have been taken. Now the question for Ramon, is it correct to use this one N4? I was never sure.
Not 100% sure either.
Okay.
I would need to check. The other thing that you notice here, okay, you're going to use the ampersand to push stuff back to the background. So with these 4 tasks, in case people wanted to do more advanced stuff, you could also do slurm the job arrays, for example.
Job array is coming later.
Okay,
Perfect. Great. So this is sometimes I use it, but not very often. But keep in mind, if you use, this is what you have to know. If you use the ampersand, you have to set this number of tasks equal to how many times the ampersand you use it. If not, just leave it 1. Okay. N, capital letter, uppercase N, remember the node is the big, is 1. C is for CPU.
The line that Giuseppe is currently in. So 1 node makes sense. And then we have 4 tasks, but you said it's 1 task per CPU. Why don't we need C4 then?
Yeah, because if you put also here 4, when you submit is 4 by 4, you see that you are using 16. So this is something that we may check together with Raymond, because I was not also sure. I use sometimes, but I'm not 100% sure.
In principle, a CPU or CPU core can do multiple tasks, but you don't want to overload it. So it's a bit of a balance thing. And so I also can't say if this will run perfectly or not. It kind of has to monitor it a bit and see if it works out okay.
Okay, perfect.
There's a question in the back, Danius.
Really a question, but a comment, because I just tried it. And the answer seems to be, no, this is not correct. Because if I run it with 4 tasks and 1 CPU, it still takes as long as a for loop. But if I try to make CPUs per task equals to 4 and 1 task in the line above, then it finishes faster.
So you say over here 4.
Yeah, here I put 4 and above and 1.
Here is 1.
Yeah, that seems to work better.
Okay, so maybe the opposite. Okay, we will check back. Thanks, Danius. It's actually something that I don't use so much. Okay, so yes.
For definition, a task in this prompt is 1 line of GDL translate, or is the whole thing 1 task?
No, one thing is 1 task. This guy. Is it correct? Yeah. Because you have the ampersand.
Yeah. So it's well, like I said, the ampersand is a bit of a tricky thing to use. I think so. Like I never used ampersand anymore. I only used the job arrays and the S run in front of it. So I would actually need to figure out what is happening here in detail, but I think it will treat it as each ampersand as one task in principle.
Okay, thanks.
I think, yeah, I think interpretation is correct.
You use the ampersand. These two tasks are very similar. So they are very extremely similar. So you could have done a for loop like we did. Okay. So when these two tasks are completely different, that the other one can run in the background, and the meantime you run also the second one, then you can use this kind of ampersand. Okay, now let's cover this last one, and then we break a bit. That is this one, resampling with the X-arc for loop. Okay, so this is one of the it start to become extremely elegant, and when you reach this kind of computation, means that you are going to achieve really high performance in the work that you are doing. The X-arc is nothing else that is a for loop that is, rather than doing the operation one by one, is going to do all together in the same time. So that's why over here we are setting the CPU equal to 4. Okay, we're setting the CPU equal to 4. We can request the X-arc to use 4 CPU. So this digital translate is going to run simultaneously a 4 digital translate together in the 4 CPU. And this one is going to take 1/4 of the time. Okay. How the X-arc work? Really simple. You list the file, and each file is becoming an argument of the X-arc. And these one are the argument that are passed to the X-arc. And when you say one, means one file, one argument listed over here, one by one. You have the main advantage of using the X-arc compared to the other that we will use is that when the X-arc will be closed, all the file will be done. Okay, it's like a for loop. All the file will be done 100%, unless there was a corruption in the file or something. Okay. So I can starting the mosaic over here after the X-arc, and I will be sure that my image is going to be mosaic back. Okay. So this is the most one of the most elegant way to do it, and then we will see other kind, the job array and the for loop again. But over there we are risking a bit that one of the tile can be not computed for some reason. We will see why. Okay. The things that you have to do it, be sure that this one they are going to take 4 times the RAM that the digital translate need. Okay, before the for loop was 1 by 1, so I was requesting 5 giga the first time, then it raise 5 giga, then it raise, and so on. Rather over here is going to be 5 giga times 4 all together. Boom. So I have to be sure that once again digital cache max is not overloading the full capacity of the memory. But again, as Raymond say, we can even remove this stuff and try to overshooting a bit more the cache max of GDAL. Okay. Perfect. So before to go to the other one, I give you a bit of time. You try to reread the script, talk among you, try to understanding the different syntax, and I will try to see why I don't have internet, but I receive image message.
Sorry, just a few information for a lunch break. It will be 12:30, so in about 40 minutes. Just another room here on the left, you will see. And there is a gluten-free dessert, but this is some of you also said that you're eating gluten-free, so please leave this dessert for those people. And yeah, that's one announcement. Another announcement, if there are smokers around, so it's not allowed here in the building, so you have to go outside, actually, in front of the main entrance. Yeah, so I'm not sure if there are smokers, so just information. Yeah. Yeah, but the lunch 12:30 in the room here on the left, you will see. Yeah.
Guys, let's comment it the last two script, and then the afternoon we will try to run and see how we modify and everything. Okay. So we have been finished this one, and we have been seeing that the most important one among this one, it was the for loop. So using one CPU, one node, one CPU, and the for loop, each single work is done in a simple for loop, okay, without any multi-core application. Then we see this one that is not very common, so we can leave it for now. And then we saw the use of Xarg. Okay, the use of Xarg is sending all the job, all the digital translate all together using, in our case, 4 CPU. Okay, now the advantage of using these in this is that whenever the for loop or the Xarg for loop is done, we can run the aggregation back of the image. We can remosaic the image, because this one, the for loop, is when it's over, we know that the for tile has been done. Okay. So now we see a bit more complex operation. We do first, we can run in one single node, in any node, one job with one CPU, in any node, okay? And then we can see also in any node, one CPU with a job array. Both of them are valid, and we will see which one is used and which one is not. Okay. So let's see the for loop. So CD. Sorry. So this one is D. D. Okay. So number of job in 4 tiles with 4 independent job, each one send it to one node to one CPU, and we don't know which one, okay? The queue system is going to take care. Okay, so the stuff to implement it is in this way. You have one node again, one CPU. Over here, you having a script that is going to be replicate 4 times with this for loop that you are going to paste into the terminal. Okay, so you are say to the terminal, run 4 job where each one is going to taking care of one VRT. Okay, so the 4 job will be independently. They can go to any CPU, okay, and any node. When everything is done, and in particular, when the last one is done, then you can reaggregate the image. But there is a caveat. The 4 jobs, one of them can be killed for any reason, and you will not know. Okay, you will know, but this one is going to run in any case. Okay, even if you say do it when the last one is over, but it cannot check the quality of the TIFF. Okay, so you will have the mosaic with an empty tile, with an empty part. Okay, but it's very advantage because it can go whenever you want, even wherever you find space between the RAM and the time of allocation that you are requesting. Okay, so it's very convenient, but there are some caveat. Then there is last way, the most elegant way, that is not, I don't want to say that is the way to go, but need to be could be combined with all the different way that we saw. And it's still called the job array, one job launching many job array. Okay. So in this case, we set up one node, one CPU, 4 job array. And we are going to launch this script below with this job. So it's not anymore the for loop, but it's only one job. And this one is going to take care because the array is going to select in automatically the list of VRT to be processed and to pass inside to the digital translate. Okay. Again, this one is elegant, but even if you requested that when the last job array has been over, you can reassemble in the image. Also in this case, if one fail for any reason, the last job is going to reaggregate maybe with one tile missing. Okay, so the 5 combination that I talk, all of them are correct, and they can be mixed, even integrate, because over here you can even have an XArc, a job array that is taking a sub for CPU. Okay, and according to what you did, you have to understand which one to use or not. Okay, so this is quite tricky to use it. So we will play a lot. We will go have a lunch at 12:30, then come back here at 1 and try to run all together the job and checking also to see what they are doing, how to run, how to testing what they are doing and so on. For now, we did let's call it the theory. Okay, perfect. Any questions? I think most of them, they will come when you try. Yeah. So one second, the XArg, you are inside one node. If the XArg if the full job is killed, is not going to go in the mosaic. Okay, so or the mosaic is done, or is not done at all. Okay. In the job array, each digital translate goes in different way, is the more efficient because he can allocate if there is one CPU that is not working, boom, is going enter. So usually you use the very job array when you have 2,000, 500, 200 stuff to run it, okay? And this is very good because you have only one job queuing with a different subtask, sub-job array waiting for entering, okay, in the queue. So it's also the IT like it because they don't overload the queue and so on, okay? Perfect. When few tasks fail, you have to check the standard error, standard output, because this one is going to run in any case, unless the last one is killed. Because this one say, if the last array is over, do the mosaic. So if the last array is killed, you don't have the mosaic at all. But if you If the second one is killed, you will have the mosaic and it's going to be miss one tile. Okay, so then you have to check in the standard output, the standard error, how to see which job has been killed and why. So there is a lot of manual checking that you have to do, still with alias and command that we will see, but it's going to be a bit manual. Okay.
Giuseppe, just maybe to add one thing to that, it is in principle possible to add dependencies to jobs. So if one fails, you could, not do the second part. That is possible to define in Slurm. Of course, the other reason.
Okay, you can do an if condition with a file.
You can also do dependent on. So you can do within Slurm depends on some other job ID. Then you split it up.
Yeah. Okay, I get what you mean. So you mentioned we can transfer all this one in another job that is pending until completion of all the others. Okay, but this is a bit more more advanced. Okay, Saverio is doing something similar in our queuing. Yeah, you can. There are different ways. You can do in the standard error, standard output to check which one are failed. There is probably some command that give you the failing ID or something, no?
In Slurm, you can check all the completed and failed jobs. So you could wrap some scripts around that look for the failed jobs and resubmit them. But this is also a reason why sometimes people look for workflow orchestrators that are above Slurm. So there are a few things like DAS can do some things. We have some own tools where you can do orchestration of many jobs on top of Slurm, because all this digging into log files, many people don't like it. But you have to kind of understand it first before you start to understand this higher level orchestration. And the more levels you make, the harder it is for sometimes to also make progress, especially for people that don't have knowledge of it and to help you.
In the beginning, you will see you are going to run 3, 4, 5, 10 jobs. So check manually. And then as soon as you start to grow in the number of jobs, you will find a solution by yourself, because manually you don't want to do it anymore.
I mean, the orchestrations you are talking about, they kind of keep track of all the jobs and retry certain number of times before they stop.
Sure, but so they will during somebody else will adding them.
So you have to go switch off your application.
Right. So Slurm itself does not really offer a way to retry. Many of these other workflow orchestrators that I mentioned can sometimes do that, depending on your desires. Whether or not the workflow orchestrator can talk to Slurm depends on whether they have defined backend for Slurm. So Toil has a defined backend for Slurm, Dask has it, Spark has it. But again, I mean, this is much more advanced. I don't think we can cover this in this week. It's pretty too tricky, and also it has pros and cons. I see another hand up.
Yeah, just one addition, that you can actually, in this case, retry a task, because in the S batch, you say array 1 to 4. If you know that your task 2 and 3, for example, failed, you can just say array equals 2-3 and then run it again.
Yeah.
But that is of course, a kind of sloppy workaround, right? So you still need to identify which ones failed, and then so.
So on that, if we were to change the script to just like array 1, it would just run the whatever top left one. Oh, okay. And just ignore the others.
Yeah, because the listing, the file selection is done over here. Here is done over here. Okay. So this one is going to select the first file, the second file, the third file, and fourth. And this is going the order is done by this. So how the LS is listing, that process is going to be the first, second, third. Okay.
Maybe if I can ask something. So some people don't like all this best metric, right? You could just create a gigantic input list and run through that as well. I mean, that is also possible.
Yeah.
Not always nice, but might be more comprehensible sometimes to people. Or pipe this command to an input list and then read it.
Yeah, what we usually do, it's something similar to that. We have because if you know the list of output, you can just run the command if the file, for example, does not exist. So if you do this check, you don't need actually to identify which job failed. You just rerun the whole process again, and it will skip the command if the file already exists.
Yeah. Yeah, you can customize as you want. These are really the simple option. Then you can, each one of the four, let's not consider this one, but you can put xarg inside the job array, or you can put xarg inside the number of jobs. You can do plenty of stuff. This one is very good when you have to transfer, you have to carry over a variable inside to the, so this one is very useful for this. Or when there's one job pending to the other one, and you need to carry the one pending in the second action. Okay?
Yeah, so just one idea for also for big data stories for presenters. If you have some experience with those kind of monitoring jobs, so you can just include in your presentation, like 1 or 2 slides, so that we can show the real examples. I also have some examples. So I usually do it with the log files and so with the error messages, and then there is actually a separate script just to go to the folder where I keep these whole things and just searching for errors. So like printing it and searching, fetching with so with command line, and then rerunning the job. So it gets a bit complicated. So you spend some time, but once you made your own system, then you stick to it and you don't want to change it. Yeah, that's
Yeah. Okay, cool. Some other question? Yes, please.
Can I run Docker containers inside this?
Yeah.
No.
No? No? I would say yes. Okay.
So you can pull a Docker container, but use Apptainer instead, Singularity. So if you pull Singularity, Apptainer is the new name for Singularity. So you can from Docker Hub or some other registry pull the Docker container image. It will auto transform it to the Singularity Apptainer CIF format, and then you can run it in user space. In principle, Docker also has a rootless option that has been advertised for about a year now. We don't trust it yet for security reasons. So all of this containerized stuff, it's a bit of a trust issue on what you do or not. So you are giving people a bit of additional privileges to do these things. And our admins have to decide, is that safe or not? So Apptainer, Singularity, yes. Docker itself, native Docker, no.
Okay, cool. And probably later on we will see the use of Apptainer, later in the week, the use of Apptainer for some specific task. Yeah. Okay. Any other question?
Yeah, maybe just to add to hack the microphones. So you don't you can just press the button, and there is immediately a queue here. So as soon as previous person who posed the question switch off, then your microphone will be switched on. And please use the microphone, because then the participants online, they can follow the questions as well. Yeah. So thanks.
Okay. Okay, we will walking a bit more, working, and then we will go for a lunch. Actually, 12:30 is already time, and see you here 1:30 back.
Yeah. So yeah, so I think now it's lunchtime. So please continue there. Yeah.
Okay, and with the alias myQ, you could see the job submission. Over here, you can see the job array. Actually, you can see that is already doing the fourth one. So the other three has been already over. And why is doing the fourth one? Because the fourth one is also doing the mosaic, the back mosaic, okay? So let's wait that then the fourth one is running. If you do error, you can see the four job array, and you can identify that they have perfect the same number of the job ID. Okay, 1, 2, 3, and 4. And then you have the second number over here that identify the job array. And these numbers are identified by A is the job ID, and the A lowercase is the array ID, okay? In the same way, you can see also the output. You can immediately see that there are no error because all the size is 0, okay? All the size of the error are 0, so you don't need neither to open. Rather, the last one, the output are, there is a function, there is something. You can also open this file in the meantime that the job is running, is not a problem. You can print, you know, the output directly by the command out, the alias L stay for last, and then more for printing. And this one is going to print immediately just the last one, okay? So you can see that these are the three commands in particular. This is the digital translate, and this is the build VRT, and the remosaic of the last one. Rather, if you take this one, the previous to the last, the third one, or even the fourth, you can see that has only one line, means that is has been computed only the digital translate. Okay, so the alias that I'm using are my queue to checking what I'm running now is empty, but I can immediately even rerun. So if I can do batch again, I can run and I can see, now you can see better. So the four job actually look immediately, they went immediately to the running phase, okay? And you have the 4 job running array, I would say. Rather, the job ID, you can see that is constant, okay? There is something also extremely useful, is the ceph command. If you take the job ID and the array, you can see all the specific of this job. In particular, the one that are more important, the time that was being used, 22 seconds, and then the memory. This is a question to ask that sometimes is not printed. I don't know why. This is a question that we need to ask to Raymond. Let's check, for example, number 2. Yeah, the same. The memory is not printed. I don't know. Sometimes it's always is happening just this time is in the cluster. In this cluster. I don't know. Here you can see the command. The work has been completed. Okay, and you can see also how many core has been used, but this one you can set it over here because we are using one node and one CPU for each single job array. Okay. So this is the more efficient way. Of course, this one is just one command, but can even over here it can be also a for loop, can even a XR condition to have a multi-core inside to a job array. Okay, can happen this kind of integration. Perfect. So I will leave to you guys to modify the script, and even when you understood, you can even already start to apply to your data in your cluster if you have, or move some data over to the cluster over here, okay? Perfect, and then we will have time to work around. Questions? Samuel is clear? also for debugging, for understanding also what is doing, you know. Try, yeah, let's do this one. To understanding what is doing this script, you can even simulate, for example, copy this export. Then, for example, you can list this one. And you can see that there are 4 files. So if you simulate a job array number 1, and you rerun the full line, you can see the file that this job array 1 is going to take care, okay? Then if you do another one, job array number 2 is going to simulate to take care of another file, okay? And so on. And this one is nothing else than the one called file that later on is reported inside to the input of GDAL translate over here, okay? So I would say play a bit and have all your scripts in running, and let's see if you can get the script running and check it with my queue, okay? Meantime, I will help you guys through the table, yeah.